Hello there! In this lesson, we're going to learn how to balance redox reactions using oxidation numbers. So remember, when you're balancing a redox reaction, not only do you have to balance the atoms, like in regular balancing, like you learned in grade 10, but you also have to keep those electrons balanced as well. So that's the new thing that we're going to add using the oxidation numbers that we learned in the first lesson. Alrighty, so you start off with a skeleton equation, and sometimes the skeleton equation will include acids or water, and other times it'll just say that the reaction's happening in an acid or base, and you'll have to add them in. So we'll start with ones that have them included, and then we'll move on to those that don't. So to get started, we're going to add in the oxidation numbers so we can keep track of the electrons, and we'll balance those first. So with hydrogen, it's going to be +1 unless it's a hydride, which it isn't. Oxygen is going to be -2 unless it's a peroxide, which it isn't. There's 3 of them, so that makes -6 overall, which means this nitrogen is +5. Here we've got hydrogen, which is +1 because it's not a metal hydride. There's 2 of them, so that's +2. That means this sulfur is going to be -2. Oxygen here. It's going to be -2, so this nitrogen here is a +2. The sulfur is going to be 0, and good old water is going to follow the usual +1 and -2. So you can see that there's going to be the nitrogen is going to gain electrons, and so that's going to be your reduction. And you can see the sulfur here is losing electrons, and so that's going to be your oxidation. Alrighty, so now that we know the atoms that are gaining and losing electrons, you want to figure out how many electrons are being gained and lost. So for the nitrogen, you can see that we went from a +5 to a +2. So that means we gained 3 electrons there. So that's the reduction. And then the sulfur went from -2 to 0. That means we lost 2 electrons. So in order to balance these electrons gained and lost, we're going to multiply this one by 2 to be 6. We're going to multiply this one by 3 to also be 6. So it'll be the same number of electrons transferring from place to place. So you put the 2 here, and you put the 3 here and here. And now you've balanced the electrons. Finally, to finish things off, what you want to do is make sure that all the other elements are balanced, if they're not already. So we've taken care of the nitrogen and the sulfur. And so lastly, we want to look at the hydrogens. We've got 2 hydrogens there, and we've got another 6 there, so that makes 8. So we'll need a 4 here. 4 times 2 will give us 8. And then let's look at the oxygens. We've got 2 times 3, that's 6 oxygens. There's 2 there, and there's 4 there, that makes 6. So that's all we needed to do is add that 4, and everything is done. We've balanced the electrons, and we've balanced the atoms. Okay, so the next thing to consider is when the atoms that are changing the oxidation numbers aren't balanced in the first place. So in that previous example, the numbers of nitrogen and sulfur on either side were the same to begin with, and so we didn't have to worry about anything. But here, if we go through and do the oxidation numbers, we got a +1 here and a -1 here and a -2. That makes -8. This is going to be +2, which means this has to be +6. Iodine 0, sulfur is -2. This is going to be +1, -2, and +1. So you can see the sulfur, there's 1 sulfur, and there's 1 sulfur over here. That's no problem. We can multiply that, no problem. But the iodine's another thing here. See, there's 2 iodines in the I2 on the right, but only 1 on the left. So you got to pre-balance. You got to put the 2 in there because those iodines have to operate sort of as a pair. And so we've got iodine going from -1 to 0, which means it's given up electrons. So we're going to say it loses. Instead of doing it individually, we're going to do the pair of them. So each iodine is going to lose an electron. So the pair of them are going to lose 2 electrons. And then this sulfur goes from +6 to -2. So that gained 8 electrons. And so if we're going to balance this, we're going to have to multiply this one by 4. So that means we put a 4 here, but then we have to multiply this by 2. So this really becomes an 8 to enable there to be the same number of iodines on both sides. And so now, because of the pre-balance, there's no problem now. And you can take care of the hydrogens and the oxygens as normal. We've got 4 oxygens, so that would be 4 waters. That makes 8 hydrogens over here, plus these 2 makes 10. We've got 8 there, plus these 2 makes 10. So we're good. We balanced the whole thing. So that's pre-balancing. Alrighty, so our next example has another wrinkle in it where one of the redox atoms ends up in more than one spot. So you can kind of see I have put all the oxidation numbers just to speed things up here. You can see that manganese goes from being +7 to +2. So that means that it gained a bunch of electrons, 5 electrons, gained 5 electrons. And then we have sulfur here, which went from +4 on this side to +6 on the other side. And the sulfur is in 3 different spots. So 3 different compounds are made that all have sulfur in it. So what happens is that all the sulfurs on the left kind of get split up when they become products on the right. Different products, different sulfurs. But they all end up with the same oxidation number, so that means that they're all doing the same thing. So that means each of these is going to lose 2 electrons. And so in order to balance things out here, we're going to need to multiply this one by 2 to end up with 10 electrons. That's no problem. We'll stick the 2 in here in front of this manganese and the 2 over here. Takes care of that. But to balance this, we're going to need 5 times this much to end up with 10 electrons that are being lost. So no problem here. We can put the 5 here. But on the other side, we have to use a little more deduction to work out where they go. So right now, use a different color. Right now you can see that there's a sulfur here, that's 1. We've got 2 sulfurs here, that's 3. And another one here, that makes 4. So we haven't got the 5 yet. And so that means they're probably on a double, either the one with the potassium or the one with the hydrogen, because we don't want to mess up that manganese. And what I see over here is this potassium already is balanced out with the 2 potassium. So I'm not gonna touch that one. I'm gonna avoid it. And see what happens if I put a 2 here next to the sulfuric acid. So now we'll look at our sulfurs. We have 5 sulfurs on this side, great. And over here we've got the 1, 2 here, is 3 plus another 2. So we've taken care of the sulfurs. So let's see what happens with the rest of things here. For oxygens, we have 2 times 4, that's 8 there. And then we have another 15 here. So that makes 23 oxygens. And over here we've got 4. And we've got 2 times 4, that makes 8. So we're up to 12. Another 8. So we're up to 20, which means we need 3 more here. So that'd give us our 23 oxygens. And we'll check to see if that took care of the hydrogens. Usually it does. So we got 5 times 2 makes 10 hydrogens on this side. And over here we've got 4 here plus another 6. That makes 10 hydrogens on this side. So we're good. So there you go. Another one that's a little different because the redox atoms are in more than one compound. Alrighty, so our next challenge here is a disproportionation reaction. So we can see we've got chlorine with a charge or an oxidation number of 0 becoming a chlorine with a -1 or a chlorine with a +5. So both are happening here. So I find with these that it is best to write out 2 chlorines on this side. We can add them up later on when we're done. So we can say that one of these chlorines is the one that's going to gain the electrons, and the other one is going to be the one that loses. Now the other thing to consider here is that these are Cl2s, and these Cls are all by themselves. So we got to do a little pre-balancing here. So the 2 chlorines makes a 2 there, and these 2 chlorines makes another 2 here. And so now we're looking at the number of electrons. These two chlorines here are going to have to gain 2 electrons in order to become these two chlorines on the other side here with a charge or an oxidation number of -1. Similarly, we're going to start with the 2 chlorines that I've just written down with a oxidation of 0, and we're going to end up with these 2 with a +5, which means we're going to have lost 10 electrons, which means that this one here we're going to have to multiply by 5 to equal 10 electrons, which means we're going to have to put a 5 here, and we're going to have to multiply this by 5 as well, making it 10. And so that takes care of the atoms that are gaining and losing electrons. And then we have to look at the rest here, and we can see that we have, we've got 3 times 2, so that's 6 oxygens there. And then we have another one here that we can alter. And then on this side, we have hydroxides. And so what we're going to need here is a lot more to take care of all these hydrogens and also provide these 6 oxygens. So I think what we're going to need is 12 total, because then we'd put 6 of them here. The other 6 would end up there, and then the doubling of the extra hydrogens here would go into the water. I think if we add that up, if we got 6 more O's, that makes 12. And over here we've got 12 O's. And hopefully that takes care of the hydrogens too. 12 times 1, 6 times 2, also the same. Great. So we took care of that one. That one had 2 features. It had the disproportionation, which you would combine in the end and just say that there are 6 chlorines involved here, and you could leave the rest of them together. And also with the pre-balancing to make sure that you keep everything balanced on either side when it comes to the electrons. Okay, great. Alrighty, so these last couple of examples are going to involve us adding acid or base in order to help balance out the oxygens and hydrogens once we've taken care of the electrons. So we're going to start off with iodine with a 0. We got oxygen with -2, which makes this one +1 for the chlorine. And then we got 3 oxygens over here. That makes -6, which means this iodine here is +5. And this chlorine here, which is, of course, a -1. So we can see that the chlorine here is going from +1 to -1. And we can see the iodine is going from 0 to +5. So the iodines we need to pre-balance, and the chlorines are fine. So we will see that we got 2 iodines here, and we're making 2 iodines with +5. So that means that the iodine lose 10 electrons. And this chlorine is going from from +1 to -1. So that means it's going to gain 2 electrons in order to do that. And so that means we're going to need to multiply this one by 5, put the 5 in here, the 5 in here, so that 10 electrons, we've got the electrons all balanced. All right, so then we get to the next part, which is to take care of the oxygens and the hydrogens. So we're going to start off by balancing oxygens with water. So we've got 5 oxygens on this side, and we've got 2 times 3, that's 6 oxygens on this side. So we're going to add an extra water over here to take care of balancing the oxygens. Then we're going to balance the hydrogen with H+ ions. We have none on the right, and we've got these 2 hydrogens on the left, so we're going to add 2 H+'s over here. And once you've done that, we have everything balanced, all the atoms and all the electrons. Alrighty, so our last one here is going to be balanced in a base. So you're going to start off the same way that we do everything. We're going to put in our oxidation numbers. We got a -2, which makes -6. This one must be +5. We've got again a -2 here, which means -4, which means this one has to be +2. We got nitrogen and hydrogen. Hydrogen is going to be +1, means +3, and this nitrogen is going to be -3, therefore, right? So we have our nitrogens that are going to be gaining electrons, right? So that's going to gain, it's got to go from +5 to -3, so that's going to gain 8 electrons, right? And then we got our zinc that's going from 0 to +2. And so that's going to lose 2 electrons. So all we need to do to balance out the electrons then is multiply by 4 to get the 8 electrons lost to match those that are gained. So put a 4 here and here. Then we're going to follow through just like we did with the acid. We're going to look at our oxygens first. We've got 3 here, and we've got 4 times 2. We've got 8 on this side. So that means we have to add 5 more waters over here to balance out those oxygens. Okay, then we got to do the hydrogens. We've got 5 times 2, that's 10 hydrogens over here, and we've only got the 3 on this side. So we need to add 7 more hydrogens over here to balance out the hydrogens. Then we get to the base part of things. So what you're going to do is you're going to put hydroxides in there to balance out any of the hydrogen ions. So however many hydrogen ions we add, we're going to add the same number of hydroxides, right, on both sides. So we're going to add 7 hydroxides over here too. Now these 7 hydroxides and 7 hydrogens become 7 waters, right? Because that's sort of what a water is. It's a hydrogen and hydroxide together. So we've got 7 waters over here and 5 waters on this side. We can cancel out these 5 waters and we end up with 2 left over. So 2 waters. And so once you've done that, you've completed balancing. Usually it's a bit messy, so I like to rewrite it. So we've got 7 hydroxides plus the 4 zincs plus the nitrate, and that's going to react to produce the 4 zincate, or whatever this is, NO2 minus 2, plus the ammonia and the 2 waters. There you go, all balanced. Okay, make sure you get some practice, and we'll talk soon.